For 8, 9, and 10, this is all about manipulating these equations so that they look the way you need them to look to pull out certain features. Like the factored form right here will show you where the zeros on the graph are, but it doesn't show you as easily what the y-intercept is. So if you want to put it in standard form, you need to multiply it out, right? You can either use a box to do that, or you can just use distributive property. So y equals 3x times x is 3x squared. 3x times negative 7 is negative 21x. Negative 2 times x is negative 2x. Negative 2 times negative 7 is positive 14. And then you combine your like terms. 3x squared minus 23x plus 14. Now, this one, number 9, is in standard form. It shows you easily the y-intercept, but it doesn't show you your x-intercepts as easily, and you'd want to factor for that. Now, I'm going to leave that for you, but if you don't remember how to factor, you can watch the video that covers number 6, and I go through factoring on that one. So that's get it in factored form. Vertex form is the one where we have, you need to use completing the square. Remember, vertex form, we want to see it in this kind where there's an x plus or minus something and then squared and then plus or minus something on the outside. So we don't use, so this is the kind where we sort of say, well, we've got this x squared term. We use the algebra tiles to model that, right? And then we've got 4x, so we put 2x on either side. And if we did that, if we had an x plus 2 and an x plus 2, right? So we can say this is definitely going to be an x plus 2 right here. But if we did that, we would need 4 positive squares to fill that out, right? We would need this to be a plus 4 situation. But we don't. We're actually missing those 4, and we have another negative 21. So we're short 4 and short another 21. So altogether, we're short negative 25 in order to make this square a complete square. So this is the vertex form, and that easily shows that there's going to be a vertex at negative 2, negative 25. Right here for the number 11 products, you can do all those yourself because that's really the same as writing things in standard form. So I'm going to leave 11A and B to you to do. That's very similar to 8, but I will do C. I'll do C because we've got some I's in here. So just to show you how it's a little different with this. So again, still distributive property. 9 times negative 3 is negative 27. 9 times negative 2i is negative 18i. 5i times negative 3 is negative 15i. And 5i times negative 2i is negative 10i squared. We combine our like terms, so really this is very similar. And that would give us negative 33i. And we still have this 10i squared, but the thing about that I squared is I squared, when you take square root of negative 1 times square root of negative 1, you actually just get negative 1. So now we can simplify further. Normally, if these were x's, you would stop right there after combining like terms, but they're not. This I squared, that's actually a number. And I times I is negative 1. So we now have things we can simplify further. This is negative 27 minus 33i plus 10. And then now these are like terms. So that's negative 17 minus 33i. So this is my final answer for C. So you do D as well. And then for 12, finding the sum, that's just combining like terms. So you're just combining like terms. Finding the difference is a little bit different. You need to be careful. So I'll do B. You need to be careful that you're subtracting both of these things. So if I do negative 20 minus 13, that's negative 33. If I do negative 5i minus negative 11, negative 5i minus negative 11i, that's the same thing as adding a positive. So that's really positive 6i. So A and B are just combining like terms.